Okay, let's do 5.6 today, equations with decimals. So solving equations with decimals works the same as with whole numbers, except you're working with decimals instead of just whole numbers. And so let's start and just kind of work some examples and go through the chapter that way. So what we have here is we have 0.3x, negative 0.3x rather, minus 6.5x, and that's equal to 6.4. So we have two negative numbers we're adding together. So 6.5 plus zero point 0.3, that's going to give us a negative 6.8x. So basically, all we're doing is taking 6.5 plus 0.3, and that was 6.8. And we still have the variable x with it, and that's equal to 3.4. Now we have to solve for x, so we're going to divide by a negative 6.8. So we divide that side by a negative 6.8. And when we do this, those cancel. We're left with x on the left. And over here, we're going to have a negative because it's positive divided by negative. And it's going to be 3.4 over 6.8. Now, the key thing here is we have to divide. We have to move this decimal over 1, and we have to move this over. So that's really a negative 34 over 68. Now, if we think about that, what is twice 34? Well, twice of 34 is 68. So 34 will go in here once, 34 will go in here twice, and so that's going to give us x equals a negative 1/2. Okay. And again, with always when you solve equations, you should always check. I'm going to leave the checks to the students here though, but if you took the negative 3/10 times this plus, minus 6.5 times this, that should equal your 3.4. Okay. Oh, and then one key thing I guess is if they wanted it as a decimal, then that would be, of course, 0.5. So it depends on if they want you to write your answer as a decimal or a fraction. Either way works. All right, so here we have these two. The x and x here are like terms, and this are like terms. So one thing I'm going to do is I'm going to take this to the other side. So that means I'm going to add 0.8. So I'm going to add 0.8. And I'm also going to take, both of these are like signs, so I can just add the two together. So if I take 2.2 and add 7.8, that's going to be 10, and that's 10, and it's going to be negative, so that's going to be a negative 10x equals. Now here I had to take 3.3 minus 0.8, and my answer is going to be negative because the answer, or the larger one, is negative. So we have, that's 2. We borrow here, so we have, bring down our point. That's going to be 13 minus 8 is 5. 2 minus 0 is 2. And so that's going to be a negative 2.5. Now I need to divide by a negative 10. So I divide that by a negative 10. Now x equals a negative 2.5 divided by a negative 10. Well, remember, negative divided by negative is positive. And when we divide by powers of 10, this is basically a power of 1, we're going to move the decimal one place to the left. So that gives me 0.25. Now we could also have done it, longhand. 10 goes into 2.5. Well, put our decimal here. That's 0. That's 2. That's 20. And then drop that and subtract. That's 5. Have to bring down a 0. And then that's going to be a 5. And that's going to be 50. And subtract that to 0. And we get there to 0.25 here. But because we know dividing by powers of 10, we just move it by that number of decimal places. So we just moved over 1. We get the 0.25 directly. Okay. All right, a couple more. Now again, with these, what we want to do is we want to get the variable parts on one side, the numerical parts on the other side, and use PEMDAS if needed to get the things simplified. So on the right side over here, we're going to have to distribute first and then work our way down and get things to the left and right and according to how they need to be. Now on the other one on the left here, we just see that we have the 8.6x here, 7.1x here, and it doesn't really matter. So let's add 7.1x and add 7.1x. Now let's take the 2.62 to that side, so let's add 2.62. Let's add 2.62. So now when we add all those together, that cancels that, that cancels that. So now what we have is, well, this is going to be a negative, and 6 minus 1 is 5. There's x still here. 8 minus 7 is 1. So that's what our left side looks like. Our right side, now if we do that, that's going to be 4 plus 2. That's going to be a 6. 6 plus 5 is 11. Carry 1. 8 plus 2 is 10. Plus 1 more is 11. And our decimal was right there. Now we just have to divide both sides by a negative 1.5. Okay. Now, we know then our answer is going to be a negative. And what are we going to do? Well, we're going to move the decimal here to the right one. And if we do that, we have to move the decimal here, right one. So really what we're going to do is we're going to take 15 divided into 111.6. And I don't know how many more zeros we need there, so we'll have that. Now we just have to divide that. So 15 times what? Well, let's see here. If we take 15 times, 7, I don't know, 35. That's going to be 10, 105. That looks like that's a good number, so we'll use 7. And that's 105. Subtract that off. That's going to be a 6. Drop down our 6. So 15 times, say 4, that's 20. That's 6, that's 60, that works. So that's a 4, that's 60, subtract, well, we get 6. Now we bring down the next 0. Guess what, 60 again, so we can just say it's a 4 again. And 60, subtract, that's 0. So our answer then is a negative 7.44. Okay. And again, I'll leave the check to the students, but you just plug that back in here, multiply this, plug it in here, multiply this, then add everything together, and you should get both sides being equal. Now here, we need to distribute. So I have to take that times that and that times that. All right, so when we do this, we still have negative 6.37 here. And then when you take that times that, that's just going to be plus 6.3x. Now, when you have to take that one, we're actually going to have to do a multiplication. So 6.3 times 4.9. 9 times 3 is 27. 6 times 9 is 54. 55, 56. 4 times 3 is 12. 4 times 6 is 24. Plus 1 is 25. Add those together. That's 7, 8, 10, 3. And we moved it 1, 2 decimal places. So that's going to be plus 30.87. And that's still all equal to a negative 1.33. All right, on the left here, we've got two values that are like terms, and then we have an x term. I think I'm going to keep this x term here, add those two together, and then take it to the other side. So if I take 30.87 and I subtract off 6.37, what do I get? Well, 7 minus 7 is 0, 8 minus 3 is 5. And now I have to borrow, so 10 minus 6 is 4, and then I have a 2. And so what I end up really with is 6.3x plus 24.5, and I can put the 0 there or not, it really doesn't matter. Let's make that 4 a little bit better. That didn't help much, and that equals a negative 1.33. Well, so now I'm going to subtract off 24.50, and so then on the left I have 6.3x equals, now those are both negative and they've lined up, so I can really just add them together. So that's a 3, 5 and 3 is 8, period. 4 and 1 is 5, 2, and it's a negative value. So now I'm going to divide by 6.3. So my x is going to be a negative. Now I have to move the decimal here once, so I have to move it here once. All right, so now I'm going to take 63 into 258.3, put my decimal there. Now 6 times 4 will give me 24, so let's take 63 times 4, so that's 12, 24, 25, so that looks good. So that's going to be a 4, That's 252. If I subtract there, that's going to be 6. Drop down that, that's 3. Oh, wow, this worked out really nice, 4.1. And so 4.1, it's negative because we had the negative up here, and that's going to be our solution to this problem. And again, I'll leave the check to you, but you add that for negative 4.1 plus that times 6.3, subtract off 6.37, should give you a negative 1.33. All right, so this one has a lot of multiplying and everything to get rid of parentheses. So we're gonna have to multiply here and here, here and here, and then we subtract off that. So what we have here first is, let's take 4.6 times 0.4. 4 times 6 is 24. 4 times 4 is 16, 17, 18. And we moved it 2 decimal places. So that's going to be 1.84. And so here we have a negative 1.84, and it's got an X on it. Now we're taking 4.7 times that. So now we take 4.7 times 0.4. Let's put our times there so we remember what we did. Now 4 times 7 is 28. 4 times 4 is 16, 17, 18. And move it 1, 2. So we have plus 1.88. That's equal to, now here we have a negative times a negative, so it's going to be positive. So now we just have to take 1.6 times 2.2, so that's 12. That's going to be a 3. That's going to be a 12 and a 3 again. So that's going to give us 352. Move it 2 decimal places. So that's 3.52. Again, it's positive. 3.52, and we have X still. Now the next one's going to be negative, so go ahead and subtract off. And so what do we have here? Well, we have 6.9 times 1.6. So 6 times 9 is 54. 6 times 6 is 36. And that's going to be plus 5 more, so that's going to be 41. And then we have a 9, and we have a 6. So it's a 4, a 10, and 11. And we moved it 2 decimal places, so 11.04. And then we still have that minus 4.5 out there. All right, so what I want to do now is I want to take and add this and this together, and then after that I can start going left and right, adding things and subtracting things off. So if I first take this, I'll have 11.04 plus 4.50. So that's a 4, that's a 5, that's a point, that's a 5, that's a 1. So what I have now is negative 1.84x plus 1.88 equals 3.52x, and then minus 15.54. All right. Well, I think I'm going to add 15.54 to both sides. And I'm going to add 1.84x to both sides. When I do that, those are gone, and over here that's gone. So now I can add those two together. So 8 plus 4 is 12, carry 1. 8 and 5 is 13, plus 1 is 14. Then my decimal, and I had to carry 1. 5, 6, 7, and then I have a 1. That's equal to. Now those are all lined up, so I have an X, and I have 2 plus 4 is going to be 6. 5 and 3 or 8 and 5 is going to be 13, and 3 and 2 is 5. So now it looks like I have 5.36x equals 17.42. So let's get rid of the 5.36 by dividing both sides by it. Now remember, whenever we do this, we have to get rid of the decimal here. So we have to move it over twice, move it over twice. So then x equals 1742 divided by 536. So 536 into 1742. Now notice they are both divisible by 2, so we could reduce it first and then makes it easier, but we can just also just straight divide it and it's okay. So 536 times maybe 3, that's going to be 18. That's going to be 9, 10. 15, 16, and that's going to work. So that'll be a 3. Now we have to add some zeros here. That's 1608. Subtract that off, so that's going to be a 3. So that's going to be 12 minus 8 is 4. 3 minus 0 is 3. 7 minus 6 is 1. And a 0. So it's going to be less than 3. So 536 times 2, that's going to be 12. 3 times 2 is 6, plus 1 is 7. Then 10. So that's going to be a 2. That's 1072. Subtract that off. So that's a 2. That's a 13. 10 minus 2 is 8. 7 from 13 is 6. Then 2. And now we have a bring down another 0. And so let's see, 2680. If I take that times 5, that'll give me a 0 there. So 536 times 5, that's going to be 30. That's going to be 15, 16, 17, 18, 25, 26. So it's a 5, and that gives me 2680. Subtract that, that's 0. So that is my answer. So x equals 3.25. And again, I'll leave the check to the student. All right. Oh, now, we have an application. So this is a good thing to have as applications for these kind of questions, because you're going to have your solving equations. So you always have to have an application with it. So it says Stella runs a business making curtains. Each month she has a fixed cost of $175. In addition, for each curtain she makes, she incurs an additional cost of $2.75. If the total cost for the month were $274, how many curtains did she make? Well, let's say X equals number of curtains made. Okay. So now let's add everything in here. So we know we have a fixed cost of 175. So we're going to have 175 plus, for each curtain she makes, she incurs another $2.75. So it's going to be 2.75 times however many curtains she makes. Well, that's X. And we know that the total cost for that month were just 274. Okay. All right, so now at this point, we've got our equation. We've got the fixed cost plus the variable cost, depending on how many curtains she made. And then we have her total cost for this month. So what do? We solve for X. So let's subtract 175 from both sides. So we have 2.75x equals, now we have to borrow, that's 1, that's going to be 16. So here we have, that's a 9, and it's going to be another 9. And so 2.75x equals 99. So we'll divide by 2.75. And so those cancel. So we have x equals 99 over 2.75. Now, because we're dividing by that decimal, we have to move the decimal on the bottom. So we have to move it 2 spaces here. Our decimal's here. So if we add a couple of zeros and move it 2 spaces, now we have the correct number on the top. So it's basically going to be 9,900 divided by the 275. And so now if we go over here and take 275 into 9900, put our decimal, probably have a couple more zeros here. So what do we have here? So if we take 275, we need 900. So if we have 300 here, if we take it times 3, that's going to give us 15. That's 21, 22, 6, 7, 8, 25. So that looks like a good number to start with. So 3, that's going to be 825. Subtract that off. That's going to be 8. So 10 minus 5 is 5. That's 8 minus 2 is 6. 9 minus 8 is 1. That's less than 275, so that works. Now we're going to bring down a 0. Now 300 goes into that. 1, 2, 3, maybe 5 or 6 times. If we take it times 6, that'll give us a 0 there. So let's see what that does. And that was times there also. So that's going to be 30. So hopefully that's going to work here. That's 42, 43, 44, 45. Looking good so far. 12, 13, 14, 15, 16. All right, we got that. So 1650. Subtract that off at 0. So it looks like she has x equals 36 curtains. That's how many curtains she made to get the total cost of 274 if each extra curtain cost 275 and she had a fixed cost of $175. So that then is our answer to this problem. All right, so this one, another example of an application problem. So children's tickets to the Ice Capades go on sale for $5.50. The Knights of Columbus has $1,200 set aside to purchase these tickets. Approximately how many tickets can the Knights of Columbus purchase? Well, let's let X equal number of tickets the Knights of Columbus can purchase. And so what we're going to do is we're going to take the price, 5.5, and we can drop that 0 because, less numbers we have in a problem, the easier. And that's times X. So each ticket costs $5.50. So if we take that times X, and we know they have a total of $1,200, we have a simple equation. All we have to do is divide 1,200 by 5.5. So when we do that, then, that cancels that, and we get X equals 1,200 divided by 5.5. Now we need to move the decimal once here, so it starts here, so we move it one time. So what we have is 1, 2, 1, 2, 3 divided by 55. And I'm hoping it's going to be an even number, but if not, we're going to approximate. So if we have 2 of those, 55 times 2, that's 110. So that looks good. So we have that, subtract that's 1, 0, bring down a 0. Now 2 of them won't go in there, so just 1 will go. So we have 55. So subtract that off. Well, that's 0, that's 9. 10 minus 5 is 5, 9 minus 5 is 4. Now we bring down another 0. All right, so if we take it maybe times 8, 55 times 8, that'll give us 40. So let's see, that's going to be 40, that's 44. So that's an 8. So that's going to be 440. So that gives us 1 0. Now we add another 0 here, bring that down. And so again, 55 only goes in there one time. And so guess what? We're kind of repeating now. So what we have then is 45. And so then that's going to be 8. So how many tickets can be made? Well, only amount of tickets can be done are there. We can't buy more than that because more than that we don't have money for because we can only get 0.18 more. And so then X then is going to be approximately 218 tickets. Okay, so that's all they can purchase for $1,200. If they had a little more than $1,200, enough to get one more ticket, then that would be fine. But we've only got enough for exactly 218, and then 0.18 more. But we don't have actually that much money, so that's how many tickets then we would actually purchase. All right, so that's all I have for the actual lecture. Now I'll go ahead and make some for some example videos.